Hi, I'm going to continue the applications of data science in various fields, and today I will be discussing the rest of the applications other than the health sector applications. So, in this application, I will be mainly discussing the application of data science in financial sectors. So, as you have seen already, that data science has diverse applications across many sectors, from improving healthcare with disease prediction and personalized medicine to enhance finance through fraud detection and assessment. In retail, it drives personalized customer experiences and optimizes supply chains, while transportation uses it for route planning and predictive maintenance. Other key applications include powering search engines and recommendation systems, enabling target advertising and improving manufacturing quality control and logistics. Now, you can also remember or you can see the last class on data science, that is the application. You can simplify the application of data science in health sector. For example, mainly here disease prediction and treatment, drug development and hospital operations. But there are lots of applications which have been presented here as the top 10 applications of data science in health sector. Now, application of data science in financial sectors or bankings and insurance companies. So mainly, for example, the people are looking for fraud detection, where they identify and prevent the fraudulent finance transactions, risk management, analyzing data to manage financial risks more effectively, algorithmic trading, using algorithms to make high frequency trades in financial markets. Now, if you want to see the detailed applications of data science in finance, then it is fraud detection, consumer analytics, customer data management, regulatory compliance, financial markets personalization, anomaly detection, evaluate the risks of investment, risk management, financial data scientists, predictive analytics, valuation, machine learning, portfolio management, credit allocation, portfolio management, algorithmic trading, personalized services, predictive models, customer service, model risk, portfolio optimization, customer segmentation, and credit scoring. Now, the application of data science, if you want to think, financial data science is the application of data science techniques in financial issues. Data science incorporates skills from computer science, mathematics, statistics, information visualization, graphic design, complex systems, communication, and business. It relies on scientific methods and algorithms to extract insights from both structured and unstructured data. Its most common techniques incorporate predictive modeling and clustering, data wrangling, visualization, and dimensionality reduction. So, what you need to know in order to get involved as a data science, or for looking, if you are looking for quick jobs, then banking sector or financial sector is one of them. You can also work from home or you can work directly in their offices. Now, what you need to know is financial data science. What is financial data science? Knowledge requirements, what amount of knowledge you need to know as the background, applying data science techniques, data science examples, and how to use the artificial intelligence or AI, how to become a financial analyst finally. Now, you can think about the data science. Financial data science is the changing how financial works, financial system works, and opening new doors for financial analysts willing to gain data science skills. What is the data science? Financial data science. The field of financial analysis uses statistical methods to understand the problems of finance. Financial data science combines the traditions of econometrics with the technological components of data science. Financial data science can use machine learning and predictive and prescriptive analytics to provide robust probabilities for understanding of financial data and solving the related issues. The field is growing exponentially. So now, the domains which you need to know, the required domain knowledge before you enter into job in as the data scientists or data analysts in the banking sector or financial sector. You need to understand financial markets, risk analytics, quantitative methods, hypothesis testing, linear regression, volatility estimation, time series analysis, simulation methods, valuation. Now, the other knowledge which you need to know: data wrangling, machine learning models, deep learning models, programming languages, in simple way. But if you want to summarize the amount of information or background you need to have before you enter as a data analyst in banking sector or financial sector, then statistical research, data processing, machine learning things, these three things you need to know. So you need to know basic computer science, basics of mathematics up to class 10, and then something, the file processing or data processing. Now, modern data scientists, what they are looking for. So this is very simple. If you have this slide or this photo with you, you can easily train yourself in just few days or 2 weeks. Maximum 2 weeks is required to get the job as data analysts in banking sectors. So these are the four domains which you need to be aware or familiar. And to get familiar or completely clear view of these four domains, you need to have maximum 1 to 2 weeks proper investment to learn these four sectors. Then you are trained enough to enter into or apply for the data analyst's job in financial sectors. Now, how to apply the data science in finance? Data science can be applied to finance in several ways. Few examples are, for example, fraudulent prevention, risk management, credit allocation, customer analytics, and algorithmic trading. So, what is fraudulent? How to prevent the fraud things? Traditional fraud detection uses rule-based models that identify unusual transactions. These models often flag legal transactions based on broken rules or fraudulent activities when millions of transactions are happening at the same time. In contrast, machine learning creates algorithms that process large data sets with many variables to find the hidden correlations between user behavior and the likelihood of fraudulent actions. Using machine learning techniques and big data analytics, banks and other financial services firms create highly efficient systems to detect and prevent the fraudulent activities, including speculative trading, rogue trading, and or robo trading, and regulatory violations. Now, the way how it works in fraud detection. So, three major applications in financial sectors are fraud detection, risk management, algorithmic trading. In case if you are looking for fraud detection, this is very clear and easy way to go for it. As a data science, you don't need to too much. You don't need to have too much background comparison to the data science application in health sectors. So here it is very simple. Understand the fraud in the digital age, the role of data analytics come here, then the benefits of data analytics, techniques for uncovering the fraud, then case studies, then the future of fraud detection. That's it. Now you move on. So data scientist enables real-time fraud detection and prevention through techniques like predictive modeling, anomaly detection, and behavioral analysis, which identify suspicious patterns and deviations and from normal activity. So these things you can make it as input parameter. It's very simple. If you are going to work in banking sectors as data analyst, you can make declare in your program that these are the kind of conditions or input guidelines or training methods for identifying this particular problem. Applications include credit card fraud, insurance fraud, identify theft, and money laundering, where algorithms analyze vast data sets to flag high risk transactions and user behaviors, ultimately improving accuracy, speeding up response times, and reducing losses. Now you can look. The key data science applications are, in case of banking sectors or financial sectors, predictive analysis, anomaly detection, behavioral analysis, and network analysis, real-time monitoring. Now you can go for types of fraud detection: credit card, identify theft, insurance fraud, money laundering. One of the major concern for any government, for any country. So, and then if you want to go for the details of types of fraud detection techniques, then here a statistical data analysis, a statistical parameter calculation, probability distribution and models, regression analysis, data matching, then artificial intelligence, data mining will help you in data mining, neural networks, machine learning, pattern recognition, and finally supervised and unsupervised learning. Now, what are the key benefits? Increased accuracy, proactive prevention, scalability, reduced false positive and false negative things. Then it means that it improves the efficiency of detection systems by minimizing both false alarms and missed fraudulent activities. So here, key benefits, you can think in the graphical way: synthetic data for model training, real-time analysis, dynamic anomaly detection, adaptive learning, combating the AI-enabled fraud, improved machine learning, data augmentation. Now, the if you want to understand the risk management, the second major application of data science in financial sectors, then you need to go for analyze the data to manage the financial risks more effectively. So how it works? You can think in this figure: compliance, stability, opportunities, analyze potential risks, predict future problems, then volatile, exposure, and or loss. So here, what you need to go for next is credit allocation. Every person who accesses or registers on a website leaves a trail of information called a digital footprint, a huge data set that is packed with all kinds of useful information. Machine learning algorithms supported by big data and high computational power can parse digital footprints to unveil the previously unknown relationship between the factors and customer behaviors. These insights can affect credit allocation and outperform traditional credit scoring models at predicting how likely a customer is to pay back a loan. So use cases of data science in fintech. For example, here you can look for credit allocation bank analyzes how open financial information, then information provided by other banks. Now customer analytics. So how will you think for the customer analytics? For example, many institutions have made customer experience and personalization a top priority. With the help of data science, they can gain insight into customers' behavior as it is happening with the help of real-time analytics to make better strategic business decisions or offer consumers recommendations based on their banking or investing preferences. For example, insurers are using supervised machine learning to understand drivers of consumer behavior, reduce losses of by eliminating below zero value consumers, increase cross-sale opportunities, and measure customers' total lifetime value. To understand customers, banks and financial systems also turn to unsupervised machine learning, where groups of similarly behaving customers groups can be identified using clustering techniques. It's very simple. So benefits of single view of customer, banks and financial systems, you need to understand in details if you are interested to get the jobs in the financial sector. Now, if you are looking for the third major application of data science in financial sectors, then algorithmic trading comes. Using algorithms to make high frequency trades in financial markets. How it works? So basically, algorithmic trading, complex system, mathematical formulas, and high-speed computations help financial companies devise new trading strategies. Bigger data in the form of growing and new data streams present ongoing challenges for the algorithmic trading models. Such models measure and describe underlying data streams. An analytical engine makes market predictions by quickly incorporating and processing massive data sets. Another application involves using predictive machine learning techniques to determine the identity of market participants. So what you need to understand, out of these three major applications, first two, fraud detection and risk management, are quite easy and anyone can start the job in this section in financial markets. But third application needs quite good experience in machine learning algorithm. So here how it works. It works automation, pattern recognition, handling big data, flexibility and ease of use, then rapid prototyping, availability of libraries. Then what are the core applications? You have already seen The core applications like risk analytics and management, fraud detection, portfolio management, and algorithmic trading. Now, if you want to see the major use cases here, like in banking sectors or financial sectors, risk analytics, consumer analytics, fraud detection, algorithmic trading, price automation, service personalization, then decision making, data management. Now, what are the other applications in addition to health sector application and financial application? Then it comes retail and e-commerce. So here also it it helps in providing personalized product recommendations to customers based on their behavior. Customer behavior analytics, understanding customer preferences and trends to drive sale and marketing. Inventory and supply chain management, optimizing inventory levels and supply chains for efficiency and cost reduction. Then it comes for transportation and logistics. So route optimization, for example, where there is a huge complex system of train, how can you route them so that there will be no missing of train when someone is going to catch the connecting trains or connecting flights. There are huge algorithmic things which helps to minimize any kind of figure loss. So basically calculating the most efficient routes for vehicles or trains or flights to reduce fuel consumption and travel time. Predictive maintenance, predicting when vehicles or machinery are likely to need maintenance to prevent breakdowns. Traffic management, analyzing traffic patterns to improve the traffic flow and urban planning. Now it comes technology and internet. For example, Internet of Things, IoT, search engines, powering internet search engines to deliver relevant results. Then they targeted advertising, personalizing online advertisements to specific audiences based on their interests and behavior. Engines suggesting relevant content like movies or music to users on streaming platforms. What are the other applications in other industries? Manufacturing, gaming, sports, energies. Now, thank you very much. Please don't forget to subscribe our channel, and I will be updating further. Please continue watching my channel.